Next up on video 6 we will continue to be working with the binomial distribution, and we're going to talk about a little bit of a shortcut we can use with a formula for the binomial distribution. And then in the next video we will talk about just using the calculator. And using the calculator can be kind of our shortcut. We still have to show some work, like we're pretending that we're doing it all by hand. And so you'll get an idea from really this video and next video, everything that you will need to do to show full work to get full credit on the test and for the AP exam. Alright, first up, in the last video we talked about doing tree diagrams, and we talked about our two outcomes we could have. Typically it was a 50-50, but we did talk about a situation that didn't involve a 50-50 in rolling a 4 versus not rolling a 4. And in each of those cases we did a tree diagram so we could see all of our different outcomes and what all the probabilities would be, because we would multiply on each branch of our tree diagram. And we looked at this example before of having 3 children, and we wanted to consider a success in getting a girl. So we could get 0, 1, 2, or 3 girls out of 3 children altogether. Well, one thing I want you to notice is when we talked about all the different ways of getting, let's say, no girls. Well, the only way of getting no girls was to have all boys. And overall, there was only one way that was going to happen, and that's if you had 3 boys. But then we talked about, well, what if you had 1 girl? Well, there were 3 different ways. Oh, yeah, not all those. 1, 2, 3. There were 3 different ways of getting 3 girls, and that could be that the first child, the oldest child, is a girl, the middle child is a girl, or the youngest child is a girl. And then we talked about all the different ways of getting 2 girls. And there was either the boy was the oldest, the boy was the middle, or the boy was the youngest. And there were 3 ways of doing that. And last but not least, the probability of getting all girls, well, there was only one way of that happening, and that was if they were all 3 girls. These numbers, 1, 3, 1, 3, 3, 1, kind of follows a pattern. And even if we change the context of the problem to flipping a coin 3 times and looking at all the different ways of getting heads and tails, if we considered a success getting a tail, well, there's 1 way of getting no tails. There's 3 ways of getting 1 tail. There's 3 ways of getting 2 tails, and 1 way of getting all 3 tails. That 1, 3, 3, 1 pattern reemerges. And that's really what we're going to talk about this video, is how to get these numbers here, these pattern numbers, okay? And it all boils down to this formula. To figure out the number of ways of doing something, a certain number of ways, we're going to be following the binomial coefficient. And for some of you, you might recognize this as a combination versus a permutation. In a combination, we have 2 parameters, 2 variables involved here. We have n, which is our total number of attempts. So for example, in our girl example, we wanted to have 3 children, so n was 3. And then k, our number of successes, could vary between 0, 1, 2, or 3. So if I did, and there's a number of ways we could write this here, so you'll see a few different examples. This is one way of writing a combination where it's NCR, where the combination is the C here. N is our number of attempts, and R is our kind of our K, our number of successes here. So you might see K used, you might see R used. The calculator itself, if you notice right over here, uses the terminology NCR. So this 3C0 is basically saying out of a total of 3 things, the number of ways that you can arrange 0 of them is there's only one way. The number of ways of arranging 3 things with only 1 is 3. And 3 combination 2 is 3. And 3 combination 3 is 1. And there are those 4 numbers again. Okay, now this only works when n is 3. If we changed n to 4, if we wanted to have 4 kids instead, we would not see the pattern 1, 3, 3, 1 emerge. We would see a different pattern emerge, 1, 4, 6, 4, 1. And some of you probably already know what that pattern refers to, and we will talk about it later. But the pattern follows Pascal's triangle, if you've ever heard of it. If you want to look it up, you can certainly look it up, but we will talk about it later. Now, really there's 2 different ways that you're going to be writing down combinations. The calculator uses this NCR command right here. And notice the way that it is written up here, not with a C, but it basically looks like we've got parentheses, and we put the N value on top and the K value underneath. So it kind of looks like we're going to be writing a fraction in parentheses with no fraction bar. That's a different way of writing a combination. So either this way or this way in the NCR calculator fashion. Now, will you need to know the formal definition here of a combination? Absolutely none. Now, some of you have probably dealt with the exclamation points here in math, which are called factorials. For example, 3 factorial is basically you start at 3 and then multiply by every number underneath it until you get to 1. Okay? So 3 factorial would essentially be 6. And then I'm asking you to divide it by k, which is just your number of successes. So let's say I wanted to have 2 girls, and then I multiply it by n minus k, so it'd be 3 minus 2 factorial. Well, 2 factorial is just 2, and then 3 minus 2 is 1, and 1 factorial is just 1, and 2 times 1 is 2. So 6 divided by 2 is the 3 that we have there. Okay, you can let the calculator calculate all the combinations that you want. You will not have to do them or show them by hand. Now, the combination command in your calculator is located at the math button. So if you want to take a look at your calculator, the math button is the 3rd button from the top on the left below the alpha key on your calculator. Hit the math button, then you'll want to slide over to PRB for probability, and then it is number 3. Now, one thing to keep in mind is if you're going to type in a combination in your calculator, you have to put the n value in first. You can't just simply go to this in your calculator, the NCR command, and then type in 3 and then 0, for instance. You'll get an error. You're just going to have to remember to type in the 3, then go to the NCR command, and then type in the number of successes, and then press enter. Alright, so we're going to work out an example here, and we're going to use our, instead of making a tree diagram, we're going to use the formula for the binomial coefficient here. Let's make this a little smaller. Alright, so a basketball player makes 75% of free throws successfully. Construct by hand a PDF table, and by PDF I mean a probability density function here, which basically is our probability model, our table here that we have been making all chapter, for 4 attempted free throws. So we have a binomial setting here because we have a success. We're going to consider that they make the free throw versus a failure, a second option that they miss. The probability of success is going to stay the same for each time, which is 75%, which means our failure rate is 25%. Each shot we're assuming is independent, that if he misses, let's say, 1 free throw, that doesn't affect the result of the next free throw. and we have a fixed number of attempts. We are only going to be shooting 4 here. So the shortcut we could write for our binomial distribution would be b4, 0.75, where the 4 is our total number of attempts, our fixed number of trials, and the 0.75 is our probability of success. Now, before I fill out the table, we're going to look at these one at a time here. And then every time we fill out one, we'll come back up here and we'll write out the probability. So x equals 0 means he misses all 4 shots. So how many different ways are there of missing all 4 shots? Well, there's only one way that's going to happen, and that's if he misses all of them. So I'm going to use H for hit and M for miss. So the only outcome would be he missed, he missed, he missed, he missed. So what is the probability that he misses 4 shots in a row? Well, each miss is 25%, so basically it's 25% to the 4th power. Now, how many different versions of this do we have? We only have one. So how we can write that, kind of as a shortcut here, would be we have one way of missing 4 shots, 0.25 to the 4th, and if we miss 4, that really means we're making 0. Now you might think it's a little silly to put this 0.75 to the 0 power. Just keep in mind that 0.75 to the 0 is really 1, and it's not really affecting the probability at all. But this way you're seeing all 4 outcomes. You're seeing here are the 4 misses, which means there are 0 hits. And there's only one way that this can be done, and that's if all 4 were misses. So altogether that comes out to be 0.0039. So we have a 0.39% chance that this player will miss all 4 free throws. Now, if he's going to make 1 out of 4 shots, well, how many different ways are there of the basketball player making 1 out of 4 shots? Well, if you think about it, let's say he makes the 1 shot on his first attempt, or he can make the first shot or his 1 shot on the second attempt, or the 3rd attempt, or the 4th attempt. So there are 4 different ways that could happen. And a way we can double check this, and this is where you can start using your calculator, is by typing in the NCR command. So you can check out of 4 shots, and then do the NCR command. How many ways are there of making 1 shot out of 4? If you type that in your calculator, it'll give you that 4 right there. So all the different outcomes, again, I mentioned were if he made the first, the second, the third, or the 4th shot was the 1 shot that he made. So the probability of each of these outcomes, each of these 4, means we made 1, but we missed 3. So each one of those 4 probabilities has a 0.25 to the 3rd, he missed 3, and times 0.75, and if you want to, you can put a little 1 exponent here, so that you can see he missed 3, he made 1. Okay, now this represents each, keep this in mind, each one of these 4 different ways of making 1. So when I come up here to my table, I'm going to say there are 4 ways of doing this all together. Okay, the 0.25, or the 0.75 I mean, in your 4 different ways is just going to be messed around here. So here's he makes the first, misses the second, misses the third, misses the 4th, versus misses the first, makes the second, misses the third, misses the 4th, misses the first, misses the second, makes the third, misses the 4th. Notice, and I'm just going to skip the last one there, where he makes the last one here, then we really have 0.25, 0.25, 0.25, that each one of these 4 are really all the same value, because they're all being multiplied together. So that's where I'm getting the 4 times all of these different things here, and I get 4.69%. Alright, now for x equals 2, that he makes 2 out of 4. Well, all the different ways that could happen are right. Well, I'm just saying, list one possible outcome. That he makes the first 2 and misses the second 2. Well, if you wanted to figure it out without actually having to figure it out, we could use our calculator. we could say out of 4 shots, how many different combinations are there of making 2? So do 4 combination 2 in your calculator, and you will find that that is really equal to 6. There's 6 different ways of making 2 shots out of 4. And each of these outcomes, let's just use this one outcome here. He makes 2, misses 2. Well, that means we're going to have 2 misses. So here's our 2 misses, and here's our 2 makes. So altogether that makes 6 times 2 misses times 2 makes, which is a little over 21%. Now for 3, that he makes 3 out of 4 shots. Well, one possible way of doing that is he makes the first 3 and misses the 4th. Well, how many other possible ways are there? Again, use your calculator. Out of 4 shots, how many different combinations are there of making 3? Plug it in your calculator and you would get that there are 4 different ways of doing that. And it's really just where the one miss is. Is the miss the last shot, the third shot, the second shot, or the first shot? And each one of those outcomes, well, if you want to put a 1 here, you certainly could. We could say 0.25 to the first, so a miss, 1 miss, times 3 hits. Each hit having 0.75, so to the third power. So we come up here. So for three successful shots, there are 4 of them, each of them involving 1 missed shot, so there's our 0.25 really to the first, times 0.75 to the third power, which is about a little over 42%. And last but not least, for our 4 ways of making 4 shots, well, there's only one way that's going to happen, and that's if he makes all 4 of them. So even if you typed in 4 combination 4, you're just going to end up with the obvious 1. You will notice that the pattern of numbers here, before we had 1, 3, 3, 1. Now we have 1, 4, 6, 4, 1. They will always they'll always be symmetric, and they'll always be a palindrome, where basically they're the same forwards as they are backwards. And our probability, well, we have 4 makes here, so really we have 0.75 to the 4th. Another way you could write it, and sometimes I will do this just to maintain my pattern, is I have my 1 for my one way of doing it, and then here's my miss probability, 0.25, but notice I put to the 0 power because I'm missing 0. And then I have my 0.75, which is my probability that I make the shot, to the 4th power because I really want 4. Okay? Now, you might think it's a little silly that I have the 0 there, but if you now glance and look overall here, you can kind of see a nice pattern emerge. That I have my 5 numbers here, 1, 4, 6, 4, 1, that I always begin those 1, 4, 6, 4, 1, and then I always put in my miss probability, too dark, my 0.25, 0.25, 0.25, 0.25, 0.25, and then I put in my make probability, 0.75 after it, and then the exponents. So with x equals 0, the 0 is where I want to see my probability of success as the exponent. And then I want to take basically my n, my 4 in this case, and subtract it from this, and that's how I'm going to get the exponent, let's use a different color here, for my misses. So if I had 4 minus 0, my miss probability, 0.25, is still going to be 4. And then if I have my 1 make, then that is my exponent here, which is not really visible. But if I put a 1 right there, so you'll notice it'll go 4, 0, then drop it down, down 1, up 1, so then 3, 1, drop it down 1, up 1, 2, 2, down 1, up 1, 1, 3, down 1, 1, 1, up 1, 0, 4. So you'll notice a pattern with the exponents. And again, I just put the zeros in there so that the pattern really sticks out in the end. And the last page here. So here are all my probabilities, and here is the overall formula for calculating binomial probabilities. We've got our combination coefficient here, and then I've got p to the k, which is our probability of success times, or really to the how many successes do we want to see, k, then times 1 minus p, this gives me my failure rate, to the n minus k power, which gives me, well, if I want k successes, how many leftover attempts do I need to be failures, okay? So let's use this formula now, and you will have to practice writing the probability statement here. If we're talking about a random variable x, for instance, if we want x to be a certain value or certain number of successes, then this is the formula that we're going to use. Sometimes you will have to use this formula more than once, as you will see in some of these problems down below. Sometimes there's going to be shortcut ways we can write it. So let's look at these three problems here. It says, what is the probability that he makes exactly 2 shots? Well, that's that value there. Okay, but the amount of work you're going to have to show to get full credit is going to be this. So makes exactly 2 shots. Now I'm going to incorporate this formula down here. Okay, so first I'm going to start off with my combinations. So I have 4 shots and I want to make 2. So 4 combination 2. And then times the probability of success, this p right here, was 0.75, and I want to make 2 shots, times the probability of failing, which is this 1 minus p, which was our 25%, and then n minus k in this case would be really 4 shots minus 2 successes, which means I need 2 failures. So you will notice that this exponent and this exponent together, they need to add up to equal the n, the total number of attempts. So if I type that into my calculator now, I should get my 0.2109. Okay, so you probably want to maybe even practice typing this into your calculator. The 4 combination 2 times 0.75 squared times 0.25 squared, just to make sure that you can verify that you do get the 0.2109.